Hey everyone, in this video we'll learn how to transform a function by stretching and compressing it. So we'll learn about vertical stretches and compressions and horizontal stretches and compressions. And as you can see right here, we have this function right here, the absolute value. F of x equals the absolute value of x plus 1. We have it drawn here on this graph. And as you can see right here, this is just an absolute value function that has been shifted up by 1. So if I were to just quickly sketch an absolute value function, it would look something like this. This would be, let's call it a of x. A of x equals the absolute value of x, and f of x in blue is just a of x shifted up by 1. So we have this function in blue, f of x equals the absolute value of x plus 1. And what we're going to learn about first is vertical stretches and compressions. So a vertical stretch slash compression. So a vertical stretch slash compression. So how does this work? Well, let's define a new function g of x. And what we're going to do is we are going to multiply f of x by k. So k times f of x. So this number right here, k, the one that we're multiplying f of x by, if k is between 0 and 1, so if k is between 0 and 1, then this is a compression. And if k is greater than 1, then this is a stretch. And we'll take a look at both examples, what the graph looks like if we compress it, and what the graph looks like if we stretch it. So let's go ahead and erase that. And let's choose a number for k. Let's choose to compress it. So g of x will simply be 0.5 times f of x. So 0.5 right here is a number between 0 and 1. So this will vertically compress the function. It will vertically compress our function f of x. So what does g of x equals 0.5 times f of x look like? Well, first let's figure out the formula. So g of x equals 0.5 times, and what is f of x? F of x right here is the absolute value of x plus 1. So times the absolute value of x plus 1. Remember when we substitute, don't forget to include the parentheses. And then we have 0.5 right here outside the parentheses times absolute value of x plus 1. So we can go ahead and distribute it. 0.5 times absolute value of x, that equals 0.5 times absolute value of x. And then plus 0.5 times 1, that's 0.5. So that is the function for g of x. G of x equals 0.5 times the absolute value of x plus 0.5. So how do we graph this? Well, what we can do is we can go ahead and start at the blue graph right here, f of x. So f of x. And what we're going to do, we notice that it starts at 1, so 0, 1. So what a vertical compression does, so this first point right here, 0, 1, it transforms it to 0, 0.5. What we're doing is we're multiplying the y-coordinate by 0.5. So 1 times 0.5 is, of course, 0.5. So we're going to transform this point by moving it to 0.5, which is right here. That's 0, 0.5. It starts right there. And we can do that with each point. So what about this one right here, 1, 2? So 1, 2 will transform to 1, And the y-coordinate, we're multiplying by 0.5. 2 times 0.5 is 1. So this will go down to 1, 1. And we can keep going. Let's just do one more example together, and then you can see the pattern. So 2, 3. So 2, 3 is right here. 2, 3 will get transformed to 2, and then you multiply the y-coordinate by 0.5. So 3 times 0.5 is 1.5. So 2, 1.5 is right here. And there we go. Let's go ahead and just do the same thing on the other side. So over here, and then it goes up 0.5 over 1, up 0.5 over 1, up 0.5 over 1, up 0.5 over 1, and 5 over 1, right there. And then the same pattern, up 0.5 over 1, up 0.5 over 1, rise 0.5 over 1, rise 0.5 over 1, rise 0.5 over 1. And there we go. So let's draw some lines. Let's try that again. There we go. So this orange function right here, this is our g of x. G of x equals 0.5x, 0.5 times the absolute value of x plus 0.5. So that's g of x. And as you can see right here, it is f of x, but it has been vertically compressed by a factor of 0.5. So g of x is just f of x, but it has been compressed. So as you can see, the v has gotten wider. It has been compressed by a factor of 0.5. So that's g of x right there. And now let's go the other way. So we've learned how to compress it. Let's learn how to stretch it. So we're going to stretch f of x. So to do that, we'll define a new function, h of x. So h of x equals, and what we're going to do, we're going to multiply f of x by a number larger than 1. So let's multiply f of x by 2. 2 times f of x. Okay, so h of x is 2 times f of x. And let's figure out the formula for that. That should mean that h of x equals 2 times, so h of x equals 2 times, and then f of x, what is f of x? That is absolute value of x plus 1. So 2 times, parentheses, absolute value of x plus 1. And we can go ahead and distribute this too. 2 times the absolute value of x plus 1 is 2 absolute value of x plus absolute value of x. And then 2 times 1 is 2. So h of x is the 2 times the absolute value of x plus 2. So that's the formula for h of x. Now let's go ahead and graph it. We can actually graph it similar to a linear equation. We see that it's plus 2. So the y-intercept is plus 2. So we can start at that point right there. And we have a slope, 2 over 1. So it goes rise 2 over 1, rise 2 over 1, rise 2 over 1, and the other side, rise 2 over 1, rise 2 over 1, rise 2 over 1. And let's go ahead and connect these points. And there we go. This green function right here is h of x. And the formula for it was h of x equals 2 times the absolute value of x plus 2. And that's what it looks like. And h of x is just f of x, the blue function, but it has been vertically stretched by a factor of 2. So that is how vertical stretches and compressions work. Now let's move on, and we're going to talk about horizontal stretches and compressions. So let's go ahead and go down here. Let's draw another graph, and we're going to use the same function. So let's go ahead and make that a straight line. And we will make this a straight line as well. Okay, so 1, 2, 3, 4, 5, 6, 7, 8, 9. -1, -2, -3, -4, -5, -6, -7. 1, 2, 3, 4, 5, 6, 7, 8, 9. -1, -2, -3. Excellent. So let's go ahead and just draw our function f of x. It's just going to be the absolute value of x plus 1, the same f of x we had up here in blue. F of x equals the absolute value of x plus 1. So we'll go ahead and graph the same one, absolute value of x plus 1. And all this is just to graph it from scratch. You start at the y-intercept 1, and then it has a slope of 1. So 1 up, 1 over, 1 up, 1 over, rise 1 over 1, rise 1 over 1, and so on. Okay, and then same thing in this direction. There we go. Let's go ahead and connect this with a line. And we'll connect this with the line as well. And that's f of x. So what we're going to learn about now is horizontal stretches and compressions. So a horizontal stretch slash compression. So let's create a new function, g of x. And to show you how a horizontal stretch or compression works, just like with a vertical stretch or compression, we're multiplying this factor right here, this 0.5, outside of the function. So we're multiplying f of x by 0.5. What we're going to do instead is we're going to multiply the input x by 0.5. So f of 0.5 times x. So f of 0.5 times x. And what this does actually, so with horizontal stretches and compressions, it goes the opposite way. So if k, so our red number right here, if this number is between 0 and 1, then it is a stretch. So this is a horizontal stretch. And if k is greater than 1, then this is a horizontal compression. So if k is larger than 1, it's a horizontal compression. If it's between 0 and 1, it's a horizontal stretch. So that's how it works for horizontals. So g of x will be f of 0.5x. Great. Now let's go ahead and figure out that formula. Well, what's f of x? F of x right here is the absolute value of x plus 1. So f of 0.5x would be the absolute value of 0.5x plus 1. So f 0.5x, f of x equals absolute value of x plus 1. That means f of 0.5x is the absolute value of 0.5x plus 1. That's how it works. So we have our g of x function right here. G of x equals the absolute value of 0.5x plus 1. So 0.5x plus 1. And to graph this, what we can do is start at the y-intercept of plus 1, which is right here. And our slope will be 0.5. So 0.5 as a fraction is 1 over 2. So that means rise 1 and then over 2. Rise 1 and run 2. So 1 over 2 means rise 1, and then we're going to run by 2. So on the graph, it goes, we start at the y-intercept 1, 0, 1, and then we're going to go up 1 over 2, up 1 over 2, up 1 over 2, up 1 over 2, up 1 over 2. And same thing in the opposite direction, up 1 over 2, 1 over 2, up 1 over 2, up 1 over 2. And let's go ahead and connect all these points right there and right there. Perfect. So that is g of x. And all g of x's, it is f of x, the blue function, but it has been stretched by a factor of 0.5. It has been horizontally stretched. So g of x is just f of x, but it has been horizontally stretched. Horizontally stretched by a factor of 0.5. Great, now let's horizontally compress it. We're going to learn how to horizontally compress it. And to do that, we're going to draw a new function, h of x. And h of x is going to be f of 2 times x. So h of x will be f of 2 times x. This will horizontally compress it. And what that will look like, if we go ahead and try to figure out the formula, we know f of x is absolute value of x plus 1. So that means f of 2x, that is the absolute value of 2x plus 1. So this is the formula for h of x. And to graph this, we know the y-intercept is 1, and the slope is 2 over 1 right here. 2 over 1 is the slope. So that means rise 2 and run 1. So let's start at the y-intercept, positive 1, which is right here. And then we are going to rise 2 and run 1. So up 2 over 1, up 2 over 1, up 2 over 1, up 2 over 1. Then again, up 2 over 1, up 2 over 1, up 2 over 1, and up 2 over 1. So let's go ahead and connect all these points. And there we go. This green function is h of x. And that is how we draw the function h of x. And all h of x is, it is f of x, but it has been horizontally compressed. It has been horizontally compressed by a factor of 2. So h of x is just our original function, f of x, but it has been horizontally compressed by a factor of 2. So as you can see right here, we have our function in blue, f of x, the original function. G of x is just horizontally stretching it in orange, and h of x is just horizontally compressing it in green. So that is how stretches and compressions work when transforming a function. I hope this video helps, and if you have any questions at all, please leave them down in the comments below, and thank you for watching.